Welcome to Chemistry Revision by Making Solutions. We run a chemistry revision website at www.revisechemistry.co.uk. In this podcast series, we're going to be going through the new 9-to-1 AQA GCSE chemistry courses. There will be 10 podcasts in total, one for each chapter of the chemistry course. Chapter 1: Atomic Structure and the Periodic Table. Atoms are made from three types of subatomic particles: protons, neutrons, and electrons. On the periodic table, you'll find every element that we know about, which in turn is a list of every atom that we have discovered. Next to each element's symbol, you will find several numbers. The atomic number is the number of protons, and the number of electrons is equal to the number of protons. The number of neutrons is calculated by subtracting the atomic number from the mass number. Protons and neutrons have a relative mass of 1, where electrons have a relative mass of 0.0005. Protons have a charge of +1, electrons -1, and neutrons are neutral. Isotopes are different forms of the same element. They have the same atomic number, so the same number of protons and electrons, but they have a different mass number, so they have a different number of neutrons. The relative atomic mass of an element can be worked out by doing the sum of their percentage abundances times by their masses divided by 100. Electrons orbit around an atom in a specific pattern. Around the nucleus are different energy levels, often called shells. Each shell can be filled to a specific number of electrons, and these limits are the same for every element. Atoms will only fill to the maximum of 2 electrons in the first shell, 8 in the second shell, and 8 in the third shell. Each shell is filled before starting the next shell. Chromatography is a method for separating dissolved substances from one another. It works because some of the coloured substances dissolve in the solvent used better than others, so they travel further up the paper. This technique is often used to separate out inks or food colourings. Filtration is a method for separating an insoluble solid from a liquid. The solid stays on the filter paper, and the liquid passes through the container below. Crystallization or evaporation is a method that separates a soluble solid from a liquid. The solution is heated and causes the solvent to evaporate, leaving solid crystals behind. Distillation is a method for separating the solvent from a solution, leaving behind the solute. This method works because the solvent has a much lower boiling point than the dissolved solute. Heating the solution allows the solvent to evaporate, and then it passes through a condenser where it is cooled and condensed into a separate container. The solute does not evaporate, and so it stays behind. Writing word equations is a great way to describe what's happening in a reaction, but symbol equations are better as they tell us exactly how much of a substance is needed or made. It is important that these equations are balanced, as an unbalanced equation will show atoms being gained or lost out of nowhere, which goes against the law of the conservation of mass. An unbalanced equation can never fully describe a reaction because it must end up with the same number of atoms at the start. Matter is often shown to be lost or gained, and unbalanced equations do not show the correct amount of each element or compound. If you'd like to know more about balancing equations, we're going to spend a bit more time in another video going through this. Through history, there have been several ideas about the atom. We can go all the way back to Democritus in about 500 BC, where he proposed the idea of atoms. However, he did not have any evidence to back this up. John Dalton in 1803 suggested that atoms were a solid sphere. J.J. Thomson in 1904 came up with the plum pudding model. Rutherford in 1911, through his gold foil experiments with alpha particles, decided and proved that there was a positive nucleus. Niels Bohr in 1913 came up with the planetary model. And in 1926, Schrödinger came up with the quantum model. The periodic table is arranged in such a way that elements with the same properties can be found together in columns called groups. Elements in the same group have the same number of electrons in their outer shell. These are known as their valence electrons. Elements in the same period have the same number of electron shells. Group 1 are commonly known as the alkali metals. They react with water to form an alkaline solution, and an example for a word equation would be lithium plus water makes lithium hydroxide and hydrogen. Group 1 metals also react vigorously when heated with chlorine gas. For example, sodium plus chlorine will make sodium chloride. Reactivity increases down the group because the outer negative electron is further away than the positive nucleus. It doesn't feel as much attractive force, so it can be more easily lost. The elements have lower melting and boiling points as you go down the group. Group 7 is commonly known as the halogens. They exist as pairs of atoms. They are less reactive down the group because the outer shell is further away from the nucleus, so the electrons don't feel as strong an attractive force, so it's harder to gain an electron. The elements have higher melting and boiling points as you go down the group, and a more reactive halogen will displace a less reactive halogen. Group 0, often known as the noble gases, are elements that have full outer shells. They do not need to react to gain electrons, so are referred to as inert. Boiling point increases down the group as atoms have more electrons, so stronger intermolecular forces form between the molecules. Metals generally have the properties of strong, dense, shiny, malleable, ductile, good conductors of heat and electricity. For those studying for triple science or the straight chemistry course, you need to know that transition metals each have more than one ion and generally form coloured compounds. These metals are often used as catalysts as they can alter the rate of reaction without taking part themselves. 4 years before Mendeleev published his version of the table, Newlands noticed similarities between elements with atomic weights that had a difference of 7. He called this the law of octaves, which was so named because he thought they were very similar to music octaves. Newlands did not think to leave any gaps for undiscovered elements and had placed more than one element into some boxes in order for a pattern to hold true. Because of this, the Chemical Society refused to publish his paper. Mendeleev arranged his table in order of atomic weight and noticed a pattern emerging too. Where the elements didn't fit the pattern, he moved them, something that Newlands didn't do. Mendeleev is most famous for leaving gaps for undiscovered elements, rather than trying to get it all to fit together. He went one step further and actually predicted the properties of the undiscovered elements, and got them right.